Okay, in this video we're going to work on some problems having to do with solutions and how to find the concentration or how to get the concentration of solutions in the chemistry laboratory. If we find a bottle on the shelf in the chemistry storeroom, oftentimes the concentration of it is way too high. On this particular example I have here, you can see here that the concentration of this is 6 molar, and that is a very concentrated solution. And hydrochloric acid does come in even more concentrated solutions, but we would be unlikely to use a 6 molar solution in the everyday chemistry lab, so we'll have to dilute this solution down to something more reasonable. So let's see how we would go about doing that. If we had a problem like this, what volume of 6 molar stock solution, like the one on the previous slide, is needed to make 500 milliliters of 2 molar hydrochloric acid solution? Right? If we look through this solution that we're trying to make, or our prepared solution, we know the volume and we know the molarity of that. So if we know those two things, we can use the definition of molarity, much like a reverse molarity type problem. We can find the number of moles of that by multiplying the molarity times the number of liters. Okay, now we have to have the molarity, we have that here, and we have to have the liters. We have to change this number of milliliters into liters. We could plug that in, and that would give us the number of moles. And then we would take that number of moles, and then we could plug that back into the molarity equation. And I've done that here. I've solved the molarity equation for the volume. So we could take that number of moles from the previous step, plug it in, divide it by the molarity of what we have to start with, the stock solution, the one off the stock shelf, and we could find the number of liters. Now, if we look at this, however, the number of moles in both cases, in both the prepared solution and the stock solution, is the same. And if that's the case, then we can set up this relationship. This turns out to be pretty simple, that if we have the concentration of the stock solution and the volume of the stock solution, that will have to be equal to the product of the molarity of the new solution and the volume of the new solution. So we will have 3 of these things, of these 4 things, and we can solve for the 4th with some pretty simple algebra. The only roadblock here might be that the volumes are in different units. So this is the setup for a dilution problem. An example problem is in a separate video.